The focus of this video is to learn three things: the 9 common polyatomic acids, the path used to find their family anions in other acids, and understand how this path will help you identify the anions in polyatomic non-acid ionic compounds. By the way, there are hundreds of polyatomic acids. However, by remembering the 9 common polyatomic acids, you can find many of their family members, including their anions and other acids in the family. So, is there a simple way to remember the 9 common polyatomic acids? Of course there is. Let us start by writing the chemical names and chemical formulas of the 9 common polyatomic acids. Notice that I said 9. Therefore, 8 of them are going to start with the letter H when you write their chemical formula. And one of them, I just simply know the entire chemical formula, which is acetic acid. When it comes to the polyatomic acids, they are broken down into families. The first family is what I call the orphans. And the orphans consist of a family of 2. I will expand on this a little bit later. The acronym that I use is CAC. So the first C stands for carbonic. Carbonic acid. The second letter stands for acidic. Acidic acid. And we already talked about its chemical formula, so I'm going to write it over here. The last letter stands for chromic acid. Now, we said that 8 of them start with the letter H. So I'm going to write an H, and then I'm going to write the rest of it. Carbonic acid has the chemical formula of H2CO3. Chromic acid has the chemical formula of H2CrO4. Next, we have the family that I call the NSP123. And this family consists of a family of 4. Again, I'm going to expand on that later. This is the acronym basically that I use, and I know that the last subscript that they have will be a 3, a 4, and then a 4. So the N stands for nitric. Nitric acid. The S stands for sulfuric acid. The P stands for phosphoric acid. And now, remember what I said about the chemical formulas. I start 8 of them with the H. So I'm going to write my H's. Why did I write these numbers? Because there's a 1 understood here. And then this one has a 2 here, a subscript of 2. The next one has a subscript of 3. And then I write the rest. Notice that I'm ending with a 3, which is this 3 over here. And then I have SO4, which is the 4 from over here. And then 4 again. So This is the NSP123 family. The last family, I call it the big family, almost like the word big as in B-I-G. And it's the biggest family. It consists of a family of 8. B stands for bromic acid. I stands for ionic. C stands for chloric. And we said that 8 of them start with the letter H. By the way, this family is also known as the Three Musketeers. And the reason for that is because they all end with the subscript of 3. So it's 3 of them, the Three Musketeers, and they all end with the subscript of 3. HBRO3, HIO3, HClO3. And this here makes the 9 common polyatomic acids. This is the same 9 common polyatomic acids. It's just that they are in a much neat format. So now that we know the 9 common polyatomic acids, what path can we use to find the family anions in other acids? For example, how can we derive the anions shown in red from the 9 common polyatomic acids? Where can we derive these anions, such as sulfate, nitrate, phosphate, and many more? The answer relies on the idea that polyatomic acids belong to specific families. For example, the orphans consist of a family of 2 members. The NSP family consists of a family of 4 members, and the big family consists of a family of 8 members. Furthermore, by remembering the appropriate prefixes and suffixes, we can use these families to derive other anions and acids. Let's take, for example, phosphoric acid, which lives in a family of 4, and let's find its family members. The focus has been to remember the 9 ic acids. Therefore, my starting point is going to have the suffix of ic. And of course, we chose phosphoric acid for this example. The chemical formula for it is H3PO4. Now, an acid that is similar chemically to phosphoric acid is going to have 1 pure oxygen. And it's going to take the suffix of us. So the name of that acid is going to be phosphorus acid. And since it has 1 pure oxygen, we're going to leave the formula almost the same, except that we're going to change the 4 to a 3. And the reason for that is because it has 1 pure oxygen. Now, according to Brønsted's Lowry theory, acids for the most part donate hydrogen ions. And whenever phosphoric acid donates its hydrogen ions, we can reveal its anion. And this anion is going to take the suffix of 8. So our anion is going to be phosphate. Now, at an introductory chemistry level, we can think of the acid as donating all of its hydrogen ions. And that is going to reveal us the charge of that anion. So we would write PO4 3 minus. So in the simplest way of explaining it, think about it like this. You remove the hydrogen ions and it gains its charge based on the number of hydrogen ions that it donated. So now, the next question is, can phosphorus acid donate hydrogen ions? Of course, it's an acid. So it's going to go from us to having an anion that is going to have the suffix of "ite." And that anion is going to say phosphite. At an introductory chemistry level, you remove all these hydrogen ions, and from there, you're able to reveal its charge. So that is its chemical formula. So the takeaway is this. We started with the ic acid. We reveal its anion, which has the suffix of 8. And since we know also the ic acid, we can reveal the other acid, the other family acid that is going to have the us suffix, and it's going to have basically one fewer oxygen. When it donates hydrogen ions, when phosphorus or whatever acid that you have here, when it donates its hydrogen ions, then you reveal a different anion. And notice that even going from top to bottom, it's also having one fewer oxygen. So we just saw an example of phosphoric acid. However, keep in mind that the NSP family consists of 3 different acids: nitric, sulfuric, and phosphoric. And they're all a family of 4. So what does it mean by a family of 4? It means that it's going to have what you see here. The suffixes ic, ate, us, and ite. Moving on, let's move to the family of the orphans. This family consists of 2 members. Okay, so remember that we start with the suffix of ic. And for this example, I'm going to be using acetic acid from the orphans. And here's this chemical formula. Another thing to remember is that acids, they donate hydrogen ions. And when they do that, they reveal their anion. And in this case, it's going to be the 8 anion. So it's going to be acetate. The thing about the orphans is that they only go from the ic acid to the 8 anion. This particular one, acetic acid, is actually donating just this hydrogen ion. And that's how it gets its -1 charge. But this one is a little bit different than the other orphans, because usually the other ones, they have the H's in the beginning of the chemical formula. Let us move now to the last family, which is the big family. And I'm going to use bromic acid as the example. Remember that this is a family of 8 members. So here we can see bromic acid having 8 family members. And the same thing for iodic and the same thing for chloric acid. They would also contain 8 family members. Notice that the big family contains the ic, the ate, us, ite suffixes. But what makes this family different from the rest is that it contains 2 extra family members in the very bottom and 2 in the very top. So when we look at the family members from the very bottom, an acid that has 1 fewer oxygen is going to have the prefix hypo, and it's going to have the suffix us. An example would be hyperbromous acid. Still going to donate its hydrogen ions. The anion would also have the prefix hypo. However, it would have the suffix ite, such as, for an example, would be hypobromite ion. Now, looking at the very top, the 2 in the top, an acid that has 1 extra oxygen is going to contain the prefix per and the suffix ic. It can still donate its hydrogen ions, and the anion is going to have the prefix per and the suffix ate. An example would be perbromate ion, or even better, perbromate anion. So notice that it's going from a 4, a 3, a 2, and a 1. The oxygens decrease going down, and the oxygens increase going up. And the same thing for the left side. They decrease going down, they increase going up. So this is everything we have covered. You have the 9 common polyatomic acids here on the left side, and then you have the path on the right side. And last, I have a cheat sheet. Remember that we have 9 common polyatomic acids. 8 of them, their chemical formula is going to start with the letter H. And one of them, you just have to remember the entire chemical formula, which is acetic acid. Then we have the orphans, which consists of a family of 2 from ic to 8. Their acronym includes CAC, carbonic, acidic, and chromic. Next, we have the NSP family 1, 2, 3. It consists of a family of 4, and they end with the following subscripts: 3, 4, 4. And last, we have the big family, consists of 8 members. They're also known as the 3 Musketeers because it's 3 of them, and all 3 of them end with a subscript of 3. And finally, I have the path that will help you find the anions and the acid family members.